Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration of the form ax plus b all raised to the power n. Now, you would recall, for dy dx, that is as good as f prime of x, and now we are setting it to be ax plus b all raised to the power n. Then we are saying that the integral of dy dx is given to be the integral of ax plus b all raised to the power n dx. Then we would have our final solution as y is equal to 1 over a times n plus 1 times ax plus b all raised to the power n plus 1. Take note, the a is coming from within the parenthesis, and the n plus 1 is coming from the power. Recall, as we integrate, we add 1 and divide by the new power. If you've forgotten, I encourage you to check out our previous integration videos, especially Introduction to Integration. And recall, f prime must be a linear expression for us to use this particular rule, and n must not be equal to minus 1, and our a is not equal to 0. Great. We will look at example 1. Find y when dy dx is 3 divided by 3x plus 1, everything squared. The solution. And we recall from the laws of indices that our dy dx can actually be expressed as 3 squared times 3x plus 1 raised to the power minus 2. Why? Because it's easier to integrate such an expression written in that particular form. Then we would have our y being equal to the integral of that new dy dx form. With that in mind, recall from our previous videos, if we are multiplying with a constant, we can take it out of the integral function so that we deal with the x terms. Now with that, we are going to have 3 squared out of the integral times the integral of 3x plus 1 raised to the power minus 2 dx. Simplifying that, we would have 9 times 1 over 3 times minus 1 times 3x plus 1 raised to the power minus 1. So what has happened is we have added a 1 to the power of minus 2 to get a negative 1. We divide with the new power, the negative 1, and the a, in our case, this is a 3. We divide by that particular 3. Now we go on to simplify what we have, implying that our y is equal to minus 3 times 3x plus 1 raised to the power minus 1 plus c. And we can actually express it as a fraction as the final answer that we have. Example 2. So example 2, we are asked to find the equation of the curve given dy dx is equal to 3 over 1 plus 2x squared, and at a point P, 1.5 on the curve. So, from the laws of indices once again, if we have fractions, we can express them in the form that is given. Dy dx is equal to 3 times 1 plus 2x to the power minus 2. And from there, we can take out the constants, which is a 3 in this case, and we integrate what is inside the integral function. Now we add a 1, we get the new power of minus 1, we divide by the new power, and we locate our a, which is a 2 in this case, we divide by that a again. Then we would have that, and then simplifying that, we would get minus 3 over 2 times 1 plus 2x to the power minus 1 plus c. And of course, we can leave it as a fraction, but before we do that, what is of concern to us is finding the value of c. Now we are given the points at which the point is located, 1.5 for the y. So we substitute for x and for y at those points or coordinates so that we get our c to be equal to 1. So as our c is equal to 1, we go back to substitute into our equation that had a c. Now, this time around, we are substituting with the 1 and expressing it as a fraction so that we get y is equal to minus 3 over 2 times 1 plus 2x plus 1 is our final answer. As easy as that. We move on to example 3. With example 3, we are asked to find the equation of the curve given dy dx to be minus 20 over 5x minus 3 squared and having a point with coordinates 4 over 5 for the x and minus 3 for the y on the curve. So as usual, using the laws of indices, we express our dy dx in that format, minus 20 times 5x minus 3 to the power minus 2, because it's easy to integrate when it is in that particular form. Now, we take out the constant, which is a minus 20 in this case, and we integrate what is left inside the integral. When we integrate what's left inside the integral, we have minus 20 divided by 5 times minus 1. And this minus 1 is coming from the power, the new power. When we add a 1 to a minus 2, we get a minus 1. And our a is a 5. We divide by that a, which is a 5. And then we add the c, the constant of integration. We simplify. Perhaps before we simplify, let's find the value of c by substituting for x value or coordinate and the y coordinate so that we get our c to be a negative 7. So with the c being a negative 7 and also reverting back to the form of a fraction, we are going to have y is equal to 4 over 5x minus 3 minus 7 is our final answer. If you've made it this far, congratulations. I'll leave you with the task. Remember, your feedback, questions, and suggestions are of great value to us. Thank you so much for watching Numbers Simplified. Don't forget to like, share, and subscribe. God loves you.